Excellent. Yeah. All right.
So we're live on YouTube, and then we go ahead and turn off our camera and wait for the 3 p.m. to come to a start.
At 1 minute. All right, I guess we can start. So I guess we can start. So it's 3 o'clock. Good afternoon and welcome back to REYES 2022 second day. And it's a great pleasure today to have Professor Sachin Shetty. He's an executive director for the Center of Security and Intelligence Critical Science in the Virginia Modeling, Analysis, and Simulation Center. He holds a joint appointment as a professor in the Department of Electrical and Computer Engineering at ODU. His research interest lies at the intersection of computer networking, network security, and machine learning. And within the last 15 years, Sachin completed many large projects with multiple collaborators and institutions. And he served as PI, co-PI on various grants and contracts funded by various military and federal government departments and private businesses. He is a technical lead for the 5G network enhancement prototype at Marine Corps Logistic Base in Albany, Georgia. He has published over 200 research articles in journals and conferences and edited 4 books. 2 of his research papers actually were chosen as top 50 academic papers in blockchain in 2018. He has received the Commonwealth Cyber Initiative Fellow, DHH, Department of Homeland Security Scientific Leadership Award, Fulbright Specialist, and inducted into the Tennessee State University $1 Million Club. He was a winner of the Electric Power Research Institute Cybersecurity Challenge competition in 2019. And he has been recognized as a top 2% scientist worldwide. He's a senior of IEEE. So it's a great pleasure to introduce Professor Sachin, and he will be taking the floor. If you have any questions, please don't forget, you can always type it on the side and we'll go over it. But again, very excited to have him present for REYES 2022. Professor Sachin, the floor is yours.
Thank you so much for the introduction, and thank you so much for the opportunity to share some of the work that my team is doing at the Virginia Modeling, Analysis, and Simulation Center. So in the next 40 to 45 minutes, I'll give you an insight on the various cybersecurity and trustworthy AI research that is going on at the Virginia Modeling Analysis Mission Center. So within the center, I run the Secure and Intelligent Critical Systems Center. So we are a center within a center. So the Virginia Modeling Analysis Simulation Center is an applied research center that looks into various digital transformation type of activities. And so I have a vertical on looking at secure systems and secure AI capabilities for our critical infrastructure. So that's my swim lane. And so I'm going to talk about various projects. So it's going to be sort of a broad strokes on a lot of the work that's going on. It'll give you insights into what are the emerging topics of research, right? Where there is a lack of technologies. So it'll give you insight into where the needs are, what type of work is going on, at least in my center, and where are we going next, right? So most of my projects are multi-year. They go into deep into this decade. So that will give you insight into, where are we going with technology. So a little bit of history of what my center has been doing, what we're doing right now, and where we're going in the future. So try to capture all that. So I always want to start with this bird's eye view. And so this is the topical areas, and always I update this every 2-3 years because the areas that we work on are so emerging and they keep on evolving that the timeline that you have to actually devote on a particular research topic, make significant advances, is getting shorter and shorter. And so these are the 4 key areas that my center is focused on. One is on trustworthy AI. So within trustworthy AI, we try to answer questions like, can we verify if the AI algorithm or the AI technique is producing results that is accurate, that is correct, the correctness of AI algorithms? And so is it reliable? Will it provide the results in different environmental conditions? So can we trust it to do so? So if I run an AI algorithm in a certain operational environment, I repeat it in another operational environment, would I get repeatable results? So that goes to reliability and verifiability. The other aspect is the fairness and the bias in AI. So there is not a lot of work already going on. People have been looking into it, but there needs to be more work because fairness and bias are really key aspects that impact a lot of aspects of where AI is used. Because if you don't understand the fairness and bias framework, you just don't know what is the frame of reference you will use to analyze the output from the AI algorithm, right? If you don't know the bias and the framework that's being used, then you don't have the ability to analyze the results within that context. And then there are other 2 that my team is looking into: how to do privacy, preserving AI. It's becoming an extremely hot topic because folks don't want to share their data for you to mine and analyze. They would like to safeguard it, but to do AI or machine learning, you need data, right? So how do we get around that if people are not sharing the data, but you need data to run machine learning? So how do you maintain the privacy? So when information is encrypted, can you still run AI techniques on it? Is encryption the only way to protect privacy? Are there other methods that we could use to protect privacy? Because customers are not going to share the data right away because they're concerned about how that would be leveraged and monetized and security concerns. So they would like you to do machine learning or AI on the data, but not data that's shared with you right away. So how do you come with creative ways to do that? And the final area in trustworthy AI is explainability. How do you explain the results? Because explainability is very key, right? If you are not able to explain the results of AI algorithm, you don't know how to act on it, right? You get some numbers, but what do they really mean? What should be my action be based on this AI analysis? So again, there's a lot of work that needs to be done on improving the trustworthiness of AI. And I tell you, that it's not even defined very well. What does trustworthiness really mean? Even definition of that everybody has different definitions on it. That also needs to be standardized. And as we speak, the National Institute of Standards and Technology has a draft out there for defining trustworthiness of AI. So once that is properly defined, then we know how to measure it, how to verify it, right? So that's again, this is where it's emerging research topics. It's not standardized. Companies are not using it yet, but that's why it's early stage research. So that's one bucket on trustworthy AI. The second area that my team is working on is secure and intelligent next-gen infrastructure. Some of you may be following the 5G and beyond investment that is going on. So we have moved from 4G and LTE to 5G and cellular communication infrastructure. And that has opened up the possibility of anything talking to any other thing, right? So this is why 5G was created, to allow anything that is on the internet to talk to any other thing. So you need ultra reliable, low latency, you need high throughput. And so I've got a couple of projects that I'm going to talk to you about that we're doing in that space. The bottom two are some of my legacy work that has been going on in the center. So I've been working with the US Navy on a lot of projects on cyber spectrum security. Spectrum, which is your communication channel, is a very precious resource. A lot of folks want to, whoever has the ability to own more of the spectrum, they can wirelessly send information out there. And so we are in a shared spectrum space where spectrum is needed for private businesses, for federal agencies, for the defense. And some of these targets are pretty mission critical and pretty sensitive. And so they will need spectrum when they need to operate. So how do we make sure that we are sharing and coexisting, right? Multiple devices that need the spectrum across commercial, federal, and defense, they can coexist and be able to operate despite needing to share the spectrum. Critical infrastructure resilience metric. This also is some of my legacy work where I started my career looking into how to measure security. That has been my big mission in a lot of my research. If you cannot measure it, you don't know how to fix it, right? And so that goes with cybersecurity. I cannot go with the assumption that it's doomsday all day and everything is bad and everything needs to be fixed. And that goes with anything in life, right? You have to do risk assessment, risk management, and then come up with a course of action. Same thing with cyber. You need to be able to measure the risk, right? Because it's all about not if the attacker is attacking you, can you operate? The good example is the human body, right? We are not going to be able to stop germs and bacteria. We can do a good job of, washing our hands and exercising cyber, health hygiene and making sure that we limit germs and bacteria entering our system. But it doesn't matter how much you do, there's always a pathway for germs and bacteria to enter your system. And if that's the case, so we are not concerned about them entering, but we are concerned about, can I still defend? Can I still continue to do what I'm doing? It's the same thing with critical infrastructure or cyber infrastructure. Attackers are going to attack. We're not going to be able to stop them. But do we have enough resilience in our system that we can survive the attack? And when does that break? And so that assessment needs to be done, because there are some attacks that are benign. Doesn't necessarily require you to have really sophisticated security solutions. So trying to figure out, not bringing, really expensive security solution for an attack, that is not going to create a lot of negative impact, right? So just balancing between the two. What is the cost I'm going to incur to purchase the solution versus what is the cost of the cyber attack, right? If that goes in the metrics, can somebody quantify the attack? If it's a crane that is going to pick up an object from, let's say, the loading dock and put it on a ship, I want to make sure if the attack is happening, can it still do that work? If it can still do the work, then the attack is not impeding from that operation from happening, right? And so those are critical operations. I need my crane to work. I want to make sure nobody on the internet can attack the controller that is controlling the crane and making sure it doesn't. I don't know if you guys heard about it, I think in Virginia where we live, I think 2-3 weeks ago, when we still had record gas prices, but somebody figured out how to get free gas from gas pumps. And the technique they used was, somebody found out that the gas pump had a mode which is basically free dispense mode. So somebody knew they had a remote to force a gas pump to be in the free dispense mode. But that goes into metrics. So that gas pump, it had this back door that nobody had closed. So it's definitely not resilient. They didn't try to come to the front door and break through. They just saw a back door and went in. And so that goes into resilience. Make sure there are no free back doors into your system, because they're not going to go through the front door and make it harder. They'll just find easier ways to get in. Okay, so that is a lot of the work. I know I spent a lot of time on this, but I just wanted you to grasp a lot of the work that's going on. Not going to spend too much time on my specific projects, but they touch upon all these areas that I talked about. So my group has developed several technologies. Again, some of my legacy work on cyber risk assessment, cyber resilience metrics, then a lot of work on blockchain. Again, I got some slides later on. We'll give you some details on some of this work. I also work with the US Navy on detecting unmanned aerial systems like drones. Got some commercial products. I've got links over here. I'll share this slide so you guys have access to it. So my center does commercial product as well as open source. So we are pretty busy on GitHub sites where we post all our code. And so a lot of the work that my team does, for the most part, except for these two, are freely available. And my center is part of several large national centers of excellence. I listed some of them are funded by the Department of Defense. The other two are funded by the Department of Homeland Security and Department of Energy. I do want to share that I have this mantra of math to marketplace. Any work that I do, I always make sure that there is a commercial partner who will be able to take the prototype and then enhance the maturity of it. So I always make sure that any work that I do, there's a pathway to adoption in the private sector, or just pathway to adoption to use in the real world, right? So if it's not used in real world, then the impact is limited. So that's a quick bird's eye view of all the work that's going on in my center. I'm just going to pick and choose. I think I got another 30 minutes. I'll try to pick and choose some of these projects and give you a quick rundown of what work we do. So again, real quick on the center, just critical areas that I just talked about. So one thing that I didn't mention is the application context. So the key application context for us are healthcare, defense, energy, maritime, and critical infrastructure. So these are a lot of the partners we work with. They have this application context. I'm going to skip my introduction. So we'll get to some of the large efforts. So I structured this into some of the large centers of excellence that my team has been part of. So here you go. So you have, this is a center that was focused on developing tools and technology to increase cyber resilience of energy delivery systems. So we developed two tools, and I'll walk you through the details of both of them. One is I mentioned about metrics to evaluate cyber resilience. So we work with the power energy regulator, Reliability First, to understand the bulk power systems, what the security risk is, and then how should we come up with the cyber resilience framework. Then you work with Accenture. It's a consulting company. So they had a product for industrial IoT. They wanted to add cyber risk and cyber resilience management. And so I and my students were able to develop the technology that was integrated into the product. So real quick. So some of the work that we have done, again, this is the work that we did with Reliability First. We looked into how to develop the cyber resilience metrics so that all the electric utilities will be able to access. We also looked into, so here's an example of the testbed. So typically what happens is when you work on areas like critical infrastructure, you don't necessarily have access to infrastructure. So we were able to work with Accenture Technology Lab, create a testbed. And so what we were interested in is that, I apologize for the graphics. So just to walk you through, So this is what we call as the IT network, typically computers connected on the internet. And then at the bottom, this is what we call as the OT network. So OT means operational technology. So this is the technology that is responsible for direct interacting with the power grid. So the problem that we are trying to solve is it possible for an attacker to, let's say, send a phishing email and compromise the machine of an analyst? And can that attack go through all these layers? There is a firewall here, there's a firewall here, there's a firewall here, and come to this breaker and trip the breaker that impacts the delivery of power? Is that a pathway? And so on the right-hand side, this shows that we were able to find a pathway that started from here. This was a known attack. And so the point of this exercise is, if we want to, this is almost like a digital twin, right? This is a digital twin of the actual power infrastructure. And we made sure that all the devices over here are similar to what you can find in the actual power energy grid. So we created this testbed and we ran the analysis to showcase that indeed a path exists. But what also we found out that if you look at the probability, it's extremely low, right? So when you see the probability of attack being extremely low, to give you a real life example, this is similar to the probability. If when I look at this number, this is definitely pretty low. So you can, whenever you get insurance, anytime when they do the risk profile calculation, right? So they figure out how concerned you should be based on this risk value. So here's an example risk. It's possible, but the probability is lower, which means it's going to take a lot of effort and time for that hacker to get in. So my team does a lot of this analysis. So given the test bed, we run some modeling. We then do some simulations on the model. This is a model so that we can then analyze, is there an attack possible? So the question is, can this breaker be tripped? It's a simple question. And so how many different pathways exist to come to the breaker? And we want to make sure we can secure against that. So that's the typical approach we take. And so we have a bunch of publications related to this. Again, you can always look up my website for some of this work. And so we took this work and then we were able to work with Accenture to incorporate it into their software stack, the software that they use to sell to companies. And so we were able to help them. And so these are the three things we added. The graph that I showed you here, this is the graph that we generated. And then we connected the impact analysis. That means we came up with what is the impact of that type, this value here, and the recommendation. Okay, so if the impact is going to be this low, what does it mean for you? What should you do? Okay, so these are the aspects that we worked on and we were able to integrate it with their tool. So another work that we did with a bulk power system is, again, we wanted to come up with this resilience metric. So if you look over here, we capture resilience across multiple dimensions. So we don't see this as only cyber. So we see the physical resilience, the organizational resilience, and technical resilience. So we use that dimension, right? So it's not only how compromised the computers are, but what about your card reader? What about your camera surveillance, right? Do you have that? Because if you don't monitor your physical spaces very well, and you only monitor your cyber, then you're missing a key portion of what impacts the resilience. The second is organizational, right? So what is your password policy? What is the access control policy, right? So the more effective the policies are, that means you only, that's a cardinal rule. You should only have access to the systems to do your job, nothing more, nothing less. And most of the times we have security issues when we provide far more access for employees to do the job that go beyond the job requirements, right? So being able to manage that very well is pretty effective. And so we came up with a way to figure that out. And we had our own framework for resilience. So it's robustness, redundancy, resourcefulness, and rapidity. So that's our framework to measure resilience. We wanted to break it down into how resourceful you are, how many resources you have, how robust your resources are to attack, what amount of redundancy do you have built in, and then how quickly can you switch over when you're under attack. And so we then start measuring for every company, right? Where do they lie in that resilience scale? So we use resilience as a combination of these R4 categories. And then we looked at in the prism of the physical resilience, technology resilience, organizational resilience. So that gives us insight into, well, this is how you fare with the R4, and your physical resilience is strong, but your organizational resilience is not very strong. So we want to come with a holistic approach of describing how to improve resilience, because improving resilience is not just patching your software and putting antivirus. It goes beyond that. So if you don't take care of the policies, if you don't take care of your physical surveillance, then you're missing a big piece of what it takes to realize cyber resilience. So this is center number 2. So the previous center work was all funded by the Department of Energy. This was a center funded by Department of Homeland Security. It's called Critical Infrastructure Resilience Institute. And so I had a project, again, this goes into my work on measuring security. So we were, this was our business proposition. We have credit scores, right, that measure our financial risk. Why don't we have security scores that measure our cyber posture? Because if I'm going to do business with a company, even when companies do business with us, they ask us for a credit score, right? When you go for a loan, they ask for a credit score to make sure they assess your financial risk. So if I'm going to do business with a company, I would like to know its security score. If I'm connecting my system to their system, I would like to know if they have a high enough security score that I can trust my data with them. Right. And so this is going to become common knowledge where I need to know everybody's security score. So I know that I'm not interfacing with a system that is less secure than me. So imagine if you had all those numbers, then you can pick and choose who you want to do business with, right? Whoever has a higher security score you'll be able to work business with. But you need an impartial way of doing this. So that's why we created this tool to measure cybersecurity posture. Again, these are some of the articles on some of the work that we did. But I do want to go into what the work really was. So the idea was to collect data on the systems and networks, and then develop this attack graph. This is the same attack graph that I showed you for the previous work, and then convert it into this scoring system, almost like a credit score, right? And so that gives you insights into where you lie. So a lower value means you're very secure, higher value means that you're least secure. And then we also want to look at where specific you have issues in. So almost like a credit score, right? But not quite. In a credit score, they give you the score, but they don't really tell you what are the 3 things you should do to improve this credit score from, let's say, 700 to 800, right? That's what you really want to know. When you have a low credit score, you want to know, okay, tell me the 3 things I should do so that I can bump up 100 points to my score, and how long is it going to take? So that's, again, I haven't heard any service or tool helping you with that. If that is one, please let me know. But for security score, that's what we want to do, right? So you get a low security score. I want to know, okay, what are the 3 things I should do so that I can bump up my security score? I don't want to fix everything because that's going to cost a lot of money. But I want to meet this threshold. Let's say I want to be a 7.5. Oh, sorry, I want to be a 1.5. Then what should be my course of action? Should I fix all the issues? Should I fix 3 issues? Just rank it for me. And then I'm just going to do that. So that goes into cost saving, right? So I do want to be, resilient, and I put the line in the sand. So that's a number. If I'm below that number, I'm less resilient, right? And so we're not talking about 100% resilience because that's going to take a lot of cost. So it's that cost benefit trade-off. So yeah, so we have a commercial software that came out of this, and that has been licensed to a company. So another center from Department of Defense, where we were focused primarily on cybersecurity methods. So this was a collaboration between Norfolk State University and Old Dominion University. Some of the things that we looked into this work was this problem of AI certification. So I talked about trustworthy AI earlier. So I wanted to figure out how to come up with a technique to realize trustworthy AI. So we came up with this approach where we want to certify AI, right? So if you use AI in a specific operational environment, can you figure out a way to um, certify that the model works, right? So if you write here, so this is operating envelope. So I want to make sure that the behavior of the model doesn't exceed my boundary. So I can certify to say that this model is going to work within this constraint, and I can guarantee you. Imagine if you're going to use AI into connected vehicles, I would need that guarantee because that speaks to the safety of the human, right? For human to be safe, I want my operation of my car to be certifiable, right? Because there are just strict boundaries. There should be strict boundaries on what constitutes safe operation. And so I want, if pretty much I see any new car, it just feels like a giant computer. I mean, that's what Tesla is, right? And so I would like to make sure that if AI is such a huge part of my system that I, as a human, operate, can I certify and know for a fact that it is going to, in this operation environment, this is how it's going to behave, and there'll be no surprises. So we came up with this technique to work on it. So we started looking at different AI models, the specific target environment. And again, I'm going to gloss over some of the details here where we started to look into where exactly the differences lie and how can we use one model for another model, and started figuring out this approach of certifying and measuring the behavior and trying to figure out how to fine tune it so that it works well in a target environment. So a lot of these efforts that are underway, and there's a large push for increasing the trustworthiness in AI. So this is one of those approaches that we feel has promise. If we can come up with a way to certify, almost guarantee the ability of that model to operate in a certain behavior. And then we use this concept of a model card. It's almost like the nutritional label on your product, right? So you look at the AI algorithm, you turn around and you see the nutritional label, which is, well, what environment does it operate in? How well does it operate, right? So for every AI algorithm, I would like to know, okay, what are your qualities, right? And so that tells me more about, are you applicable to my environment or not? So we have a concept called model card, almost like a nutritional label that you can share, and people know whether they want to use your model or not use your model, and things of that nature. Okay. So I think this is just some accomplishments for the center work that we did. This is a new center that we have been involved with. This focuses all on AI and machine learning. And so as you can see, a lot of the trustworthy AI work that I talked about, trustworthy AI decision-making, contextual reasoning and explainable AI, how to make sure your AI is resilient to attacks, federated and distributed. So federated is another technology to make sure that you don't share your data. So you share the model, not the data. So the customer will be able to safeguard their data. And then how to run AI algorithms with high performance resources. Some of the AI algorithms are pretty resource hungry. And so how do we make sure that we have the ability to run high performance capability? So again, this is an ongoing work. Next time, if I have the ability to, the opportunity to share, I'll be able to share more results coming out of this center. So wanted to share with you a large project that I'm leading. So the Department of Defense has been investing a lot of tax dollars in making sure that our Army, Navy, Air Force sites infrastructure is cutting edge. So to that end, there's been a lot of investment in 5G. And so I'm the technical lead on this effort for a 5G enabled smart warehouse at the Marine Corps Logistics Base, Albany. So it's a pretty large effort involving multiple academic institutions and companies. And so this is the problem that we're solving. So the warehouse in Albany, Georgia, it's running to a legacy warehouse system and process. And the legacy warehouse system and process, results into a lot of logistical inefficiencies. So you have a vulnerable cyber environment. Inventory management is challenging. You just don't know where your stuff is. You waste a lot of time trying to find things that you need. And there's just so much manual labor involved. So Our solution was that, is it possible for us to leverage Internet of Things, devices and sensors, and the 5G infrastructure to overcome these 4 problems? And so that's the proposal that we have. So if you look at the key processes in a warehouse, the receipt, the storage, the handing the kit, the issuance and delivery, can we use 5G infrastructure to automate all of these activities? And so that was our goal. Again, what's the purpose? Especially with warehouses, the key question is, where's my stuff? Where's my device? Where can I find it? Can I geolocate it to centimeter level accuracy? Like that bay, that shelf, that level. Can I really get to that on my iPad, right? And so imagine the ability to track so many assets within the warehouse on your iPad, where you know exactly where that item is when somebody moves it. So let's say you can almost create a geo fence, right? If some object is moved beyond a certain bay, if it's supposed to be bay 3 and somebody moves to bay 4, you get an alert because you set that tracking to the device to make sure that it never moves beyond a geographical parameter. So you can see you can use that for security a lot, like just warehouse physical security. But imagine how much quicker your process will expedite, because you can audit things better, you know where things are, and it's going to make a huge difference to the efficiency, and it's going to have a ripple effect on the processes that depend on all the information. You can imagine if one warehouse is tractable and if they can replicate this to other warehouses, that's going to speed up the tracking process. And that's really one of the time consuming aspects of warehouse operations. So we have, again, not going to go into too many technical details. So we as a team proposed 2 methodologies. One is called the resilient distributed positioning network. So the concept is to have enough beaconing nodes in the warehouse that can help geolocate the devices. And again, our technique provides the ability to detect any device within a centimeter level accuracy. Another technique that we're proposing is called the distributed coherent massive input, massive output capability. What basically means is that one of the challenges in the warehouse is coverage. To make sure that every single device is covered, right? It's one thing to so I can position you at a centimeter level accuracy, but if I can't cover you, I don't know where you are, right? I need to be able to cover, I need to be able to provide you wireless coverage, then I can locate you, right? So the coverage comes first. If I can cover you, then I can track you with high accuracy. So that's the other piece where we're looking at the ability to cover every device in the warehouse, because it's challenging because there are small devices that are stuck in different places. And so that's the work that we're doing. Okay. So I want to talk about the regional impact of critical infrastructure security. So some of the work that I'm doing is on blockchain for healthcare security. And so the work on blockchain looks into, at least for this effort, we are looking into how to protect medical devices. And so this is a platform that my team developed to help ensure that the authorized devices are communicating. And so the authorized devices are always communicating in authorized places. Okay, so so that is the objective that we have. And so we presented this to a couple of symposiums and got a lot of visibility from our work. Again, if you're interested, I posted the link. You can look at what the platform does. So this is a little bit of technical detail on the work. So as I mentioned, we are tracking the network traffic. So that's our solution. We track the network traffic, and then we come up with this profile. We create a profile of the device. And through that profile, we are able to identify, is it authorized, not authorized? If it's authorized, is it communicating with the authorized device, right? So we are tracking not only are you supposed to be on the network, but are you engaging in authorized communication, okay? So this is the next work for Port of Virginia, where Port of Virginia has been interested in 5G. One of the reasons why they're interested in 5G is they're extremely concerned about GPS spoofing. GPS is what they use to track devices because they have a lot of trucks and trucks loading into containers. And there are efforts out there how to jam GPS and spoof GPS to where you can use GPS anymore. And so they have been looking into 5G. So you can see the parallel, the 5G work that we are doing for the warehouse for tracking. The Port of Virginia wants to use the same thing for tracking the trucks, where the trucks are going, where the trucks should be going, where should be they loading, unloading stuff in the containers. So the reason why that is important is that so we need to know where the trucks are. We need to make sure there's optimal assignment trucks to common areas. Again, it helps with route planning a lot. And again, keeping the information secure and private is very critical. So we have an established 5G test bed, and so we have been able to leverage it and interface it with the Port of Virginia's infrastructure. Also, I wanted to end on some of my other work on drone detection. So this is the work that I started with my undergraduate student when he was a freshman. And so our initial tasking was how do you detect whether we have a drone flying in the air or just some other random signal. And so what started with this, just collect all the wireless signals, analyze the wireless signals, and then figure out whether it's a drone or a not drone. And then we started looking into, well, how about we can reduce the form factor, right? We don't want this running on a large computer with a lot of resources. What if there is a warfighter that is out there, not connected to the cloud, and would want to scan the wireless environment nearby, look for signals, and then be informed if there is a drone in the air and whether they can trust it or not, right? So you can imagine that type of capability is going to be so valuable. And so we decided to, again, I don't know if it's clear here, there are some small devices on this figure here. So we were able to get that form factor down to where you can almost put that on your backpack. And what it does is it just scans the entire radio frequency band and just starts picking up signals. And if it sees a signal that is seen before, is it noise or is it some other wireless device, and if it's a drone, we then dig deeper into it, and then we're able to find out how many drones are there in the channel, what brand of drone it is, right? So we just try to get more useful information about the drone, so that it's more situational awareness, right? For any warfighter out there, while they go out there, it's always good for them to know what type of transmitters are there, right? What type of signals I need to be concerned about. So having the capability, so we call this the radio frequency signal classification. Again, this is for drone detection. But I would say that this is a capability where if you provide this to warfighter, where they provide those frequency bands that they're operating in, and they want to make sure that when they operate in those frequency bands, there won't be any attacks, right? So they want to be protected. So that's why this is the work that we did with my undergrad student. We, again, not only designed the technique, so there's machine learning involved here. So we had to come up with a machine learning technique that will indeed work on a small form factor. So we had to work with cost effective in terms of resources machine learning algorithm. And we were able to implement this and also test it out in a lab setting. So this is my lab at VMask, and you'll see this new story where we collaborated with Naval Surface Warfare Center Crane, where they gave us access to their drone ranges. So there was one drone range in Indiana, another drone range in Arizona. So this is the beauty of our work. We had signals that were collected in VMask. We were able to train our machine learning model to run in VMask. And so that same machine learning model, we were able to take it to these two drone sites. And it didn't take more than 5 minutes for that machine learning model to quickly figure out this new environment. Remember that earlier research I was talking about, can your machine learning model work in different environments, right? How long does it take for it to adapt? And so it took us 5 minutes for a model to detect this new environment and then start detecting the drones in the area. And so we were able to get some good ranges. So I think it's a little too easy when there's nothing out there. So when you go to these drone ranges, they're pretty much, there's no urban type of environment where you have a lot of obstruction. So it's pretty much clear, but still we will to detect a drone at 75-kilometer range. So I think that was significant because we are really running on low power, low cost devices that probably cost $1,000. And so these are really cost effective devices, if we have, because we want to make sure that somebody can carry it and still detect a drone at 75-kilometer range, which I think is significant, right? So if it's a drone that maybe is spoofing, or if the drone is maybe eavesdropping, it's good for the warfighter to know, right? So in my mission, there should be no drone, but now my detector is saying that's a drone 75 kilometers away. So it gives enough time for the warfighter to then determine the course of action, right? What should they do next? Because they detected something that wasn't expected. So this is one of the work that we started again as a math problem and then made it all the way to this evaluation and verification at this drone ranges. So I see the time, again, some more technical details on how we did it. This is just guts of the work. Again, if folks are interested, we had a paper published a couple of years ago. And so we call this automated radio frequency classification so that we can detect and classify multiple signals across multiple bands. So we have the software that we developed that basically reads radio signals and analyzes. And so, so this work is now, getting more refined, and warfighters are using it for just different contexts, because there's always an interest in scanning the environment, checking is it a friendly signal or unfriendly signal, and getting more insight into what transmitters are in there. That's a very important problem. And to be able to do that in automated fashion, that if you don't repetitively do it over and over again, it's very effective. So I want to talk about some technology and commercialization. I know against time, I'm going to quickly go over this. So this is the tool that is now made available to over 200 electric utilities. So they can now measure their resilience using this chart. And so that gives them every day when they run it, or every month when they run it, it gives them good insight into how resilient the infrastructure is. We shared one of our work with the Electric Power Research Institute. So they were able to use this for, again, their utilities that they work with. So similar concept that I shared earlier about collect network data, run a tie graph, and provide analysis and course of actions. So Chrism, as I mentioned, it's we partnered with a startup company to commercialize this. So a lot of work that we have done, the last three work, they are now already being used by the private sector. And this is the blockchain work that was jointly done with Centera Healthcare and Old Dominion. And so the solution is, how do you have reliable medical device security solution using blockchain, where we can make sure authorized devices are on the network and authorized devices are engaging authorized communication. So that's the twin problem that we're solving. And I mentioned about this Accenture tool where we were able to insert our recommendations. Those are the three things we inserted. And this is my team. So nothing works without having a reliable and proficient teams. I've been very lucky to have it. A bunch of faculty, postdoc researchers, PhD students, and software developers. So who take my vision of math to marketplace. That's about it. So I know, I think I'm at exactly 45 minutes. So I'll be happy to take any questions.
Oh, wonderful. Thank you so much for the presentation. It's great. So we have few questions here. Again, if you have more questions, we'll try to put them into, one category and ask them one at a time. The first question I had is, what courses or training do you recommend to study AI?
So I think in order to study AI, the good news is that there's a lot of material online. So I would say the prerequisites for AI is going to be some statistics. I think statistics would be a good course, or at least capability and knowledge to have. And programming, I would say knowledge of statistics and programming would be great. I think that'd be a good start, because the statistics would give insight into how to analyze data and convert it into a model, and programming will help you automate this. So just understanding, because that's what machine learning is. You take data and you convert it into a high level of understanding. So statistics is a good tool to know about, because that's what you do in statistics. You have a lot of data and then you start abstracting it to some high level representation, right? So when you do average or standard deviation, you have a lot of data, but you came up with this one singular metric. So once you understand how to do that, then you're able to do some sophisticated work. But that conceptual understanding of how to take a lot of data and just convert it into a single number. So that's why I mentioned statistics, because that will provide you the foundation of how to learn AI.
So a couple of other questions that just popped in. So what are the best way to get some papers published as an undergrad?
As a matter of fact, I'm glad you asked that. So when I was spending a lot of time on the radio frequency work, so that student who was standing next to me was an undergrad student. And so it didn't really matter, because the work he did was so good that, again, it's a teamwork, right? So yeah, if you are lucky enough to work with a research group, even if you're undergrad, you can start implementing in engineering. So there are a lot of conferences that accept system papers, right, where you're not coming with a mathematical theoretical technique, but you are improving the system performance, right? So most of the undergrads are very good with knowing systems, right, because they like to tinker around. And so if you're an undergrad student who likes to tinker around with systems, and what is a paper? It's basically, providing some insight that nobody knew. So if you know of a way to either break into a system, if you know of a way to enhance the system, then that's a contribution. And so there are system conferences where it doesn't really matter whether you're undergrad or not. If you have something interesting discovery, then it's always welcome.
And one question came in. Do you happen to have a GitHub repository?
Yep. So I think a lot of the work that we have multiple. They're not in we have not organized in one. We probably should. But yeah, we do have multiple GitHub repositories. So I can share my slides
Please,
with you guys. So then if you have any interest in any specific tool that we're developing, we can share you the GitHub link for that. And yeah, we haven't consolidated. I think that's a great idea. I probably should consolidate everything in one place so that you can access it. So yeah, but I share the slides, take a look at the work that we're doing and pick the work that you're interested in.
All right, wonderful. And he's at Virginia Modeling and Analysis and Simulation Center. So if you have questions too, you can email Reyes and we'll definitely connect you with Professor Sachin. One other question I still don't understand. It says, how do you feel about non-fungible tokens, NFT?
Yeah, so it's just another trading mechanism, right? So I think, I don't know if you are tracking metaverse. There's a lot of interest in metaverse. So I feel like this economic transaction of digital artifacts or just anything of value, right? That's what NFT is. Just anything out there, you can assign a value and you can trade it. And it's here to stay because there is a market for it. There are buyers and sellers. So anytime you have buyers and sellers of any commodity, and if there's somebody to put the value to it, that's really what is happening, right? And so with metaverse, I would really like you to look into metaverse. And there have been a lot of activity going on in metaverse. And I think NFT is going to play a big role in terms of how you trade assets and how do you derive value. That's, not everything is captured through cash or dollars. There is utilities also attached with it. So that's here to stay. I mean, same thing with cryptocurrency, right? So this is just in that realm of going away from traditional way of payment to non-traditional. So it's here to stay. I don't know which one will crash, which one will emerge with anything, right? There's a lot of different ways to do that and will converge to something. I don't know what the something is going to be, but there'll be some alternative to cash. That's just my opinion. I see, but it does look like the industry is a little unstable. But with any innovation, it takes a while. But I think the metaverse is here to stay. So there will be some means of this transaction that is beyond cash. You just don't know. It's NFT right now, maybe something else.
But would you invest in it?
Well, I would not invest in it because even though I've done blockchain research for a while, it's still unstable. I think the stability is still a problem. So I personally invest in more stable type of assets, right? So, and that is high risk, high gain, right? So
That's right.
that's always that. When you look at your portfolio, how many of your portfolios are stable portfolios, how many portfolio high risk, and that's the risk you take. If you it's still high risk. I don't think it's stabilized, but that's always the case with assets. There's some assets that are stable, but rate of return is going to be lower, but you live with it. But some asset is day or night, so you live with that too.
One more question. So how to get the slides? You can always email Reyes at Reyes, REYES at odu.edu, and we'll be glad to provide with you, we provide the video too, because this is recorded, and some of the slides. So don't forget, you can email Reyes, REYES at odu.edu. So here's an interesting question I didn't think about. It asks, what do you think is the best way to authenticate sentience with an AI?
Yeah, I think it's possible, right? I think it's we say Internet of Things right now.
Yes.
In 10 years, we'll have Internet of Senses.
Oh, senses.
Yeah. So again, so for us to have Internet of Senses, we have to figure out how feelings will be inserted into AI. And is there a way to incorporate that? So it's interesting because now we are talking about we see computational models providing more objective reasoning, but then this will get into more subjective decision making because you're incorporating feelings and awareness. And so again, I haven't looked at the Google AI to see whether what level of sentience can be provided. I do know that it's extremely polarizing topic, right? When you talk about a computational model having feelings, and what does it mean? What are implications, right? Where do we incorporate it? Because now we're talking subjectivity incorporated into decision making, and that is risky. Yeah. So again, the jury is still out. I don't know how much. I know the Google AI has been pushing for it, but I just don't know the level of subjectivity it has, awareness it has, and feelings. So that remains to be assessed. But yeah, it's a very polarizing topic. I think this is where we get into the ethical part of AI. So AI ethics is going to be pretty huge. We have to get our head around AI ethics because this topic that we're discussing is really straddling AI ethics. And so the technology is moving so fast, we are just not able to standardize all this, so especially AI ethics. I don't think it's out there, but I don't think it's standardized yet.
So one student asked, or one person asked, what are some other projects that you are interested in right now? So I like the healthcare. You'll speak more into it.
Yeah. So right now, so the one project that I'm interested in, I was not able to share is, I've been very interested in, given the three technologies, 5G, augmented reality, and AI. And I feel like these three technologies are going to help with this one problem that we all as a society have. How to bring expertise to the point of need. So let's take a healthcare example. So let's say you have somebody in the rural community who doesn't have healthcare access, like surgical healthcare access. Right. And so there's a surgeon sitting in some other part of the world, and this person in the rural community needs that surgeon's expertise. But this person is not physically located there. This person is somewhere else. So expertise to the point of need. How do we bring it? And so using 5G, the communication infrastructure, the AR, VR, the immersiveness, where the surgeon feels like the time and space doesn't mean anything. Right. So I collapse time and space. And so if you're looking for a mole on my cheek, it's almost like I'm there examining the mole. I'm not doing surgery on you, but to be able to tell a general practitioner doctor that is living there, to be able to guide and get more information, that is, that's where we like the knowledge, right? Then there's knowledge so many places. but how do you bring it to the point of need where people really need it? And so that's something that I'm really fascinated by, because it's going to help a lot of people who just don't have the means to go to, especially healthcare, because I'm more focused on people's health, right? So we are talking about this impact is very huge. If somebody can just get a second opinion from a surgeon that they didn't think was possible. So yeah, so that's a project I'm really excited about. So in VMask, we are just acquired a 5G testbed. We have some good AR VR capabilities, so we are now connecting the two and trying to figure out, can we really immerse somebody? Because see, we don't want the experience to be not good.
Yes.
So we want, when I say time and space, well, is it really, does it take 10 milliseconds or does it take 100 milliseconds? Right. So, to make sure that the experience is truly immersive. It's almost like I'm right there. Okay.
That's right. Wonderful. Yeah. Any books, or do you want to, any books you would recommend reading more on?
Yeah, I can maybe let me draft an email when I share the slides. I'll do it.
Okay, yeah. Okay, wonderful. Yeah. So again, if you have questions, please don't forget, you can always send an email,
right? And
we'll be glad to answer all of them.
Okay.
And so there's going to be more talks. One last question, I guess. How do you see data sharing, data governance in AI?
That's governance is a huge topic. So I think it's a political topic, and I would say that it's just hard to say. Again, I go back to standardization. Somebody needs to set the standard. If you don't, then everybody's going to do what they want to do. Right. So if the standards are not set, then nobody has the requirement to meet those standards. So there are many ways of data sharing being thrown out. My biggest concern is, who is monetizing from your data? Because somebody is, right? And so I feel like as a data owner, I should be empowered to decide who gets access to my data.
Yes.
And how do they monetize? If I don't have the transparency, then I'm sharing my data with no idea about the value that's derived and who it is impacting. The data owner should know that. But right now it is not set up that way. But hopefully it will be in future.
Hopefully, yeah, hopefully so. Well, I think those are the questions we have. We want to thank you all for joining us today, and we want to give a good, thank you again for Dr. Sachin for presenting today on cybersecurity and trustworthy AI. Very fascinating topics, So again, we look forward to seeing you next, and thank you all for joining us today. Appreciate you. Bye, everyone.